Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.11 to 2.14. First problem 2.11. Draw the output voltage waveform for each circuit in given below figure. These are two circuit diagrams of given problem. We have to find out the output voltage waveform in each case. We will start from here. If we observe, this is an half wave rectifier and an AC input voltage is applied across its input terminals. This voltage have peak value of 5 volt and we have to determine the output voltage waveform across resistance R having the value of 47 ohm. We know that in case of half wave rectifier, as name indicates, only half cycle of the AC input waveform is rectified through diode, while the remaining half cycle is not allowed to pass through diode. Orientation of diode in circuit diagram determines either positive half cycle or negative half cycle will be rectified. Now we will try to find out the output waveform of this circuit diagram. During the positive half cycle of AC input waveform, this terminal will be positive with respect of this ground terminal and this terminal will be negative. So the anode of diode will be connected to positive and cathode of diode will be connected to negative terminal of AC input voltage. If we recall the conditions for the forward biasing of a diode, the first condition was the anode of the diode should be connected to positive terminal and cathode of the diode should be connected to negative terminal. Second condition was that voltage across the terminals of diode should be greater than potential barrier of diode. Here we are assuming this diode as a silicon based diode and AC input voltage have peak value of 5 volt, which is much larger than the potential barrier of silicon diode. So we can say that during the positive half cycle of AC input voltage having peak value of 5 volt, this diode will be in conducting or in forward biased mode. And we also know that whenever a diode conducts, it allows current to pass through it while having a potential drop across its terminals of 0.7 volt. So during the positive half cycle of AC input voltage, we will be getting rectified output voltage which will have peak value of 4.3 volt. Now we have AC peak input 5 volt minus drop of this silicon based diode which have 0.7 volt across it. So we will be getting 4.3 volt peak on output voltage waveform. Now as we discussed earlier, half wave rectifier rectifies only half cycle of the AC input voltage. In order to prove that, we will focus on negative half cycle of this AC input voltage. Now we will consider this negative half cycle of AC input voltage. During this negative half cycle of AC input voltage, the voltage polarity across these two input terminals will be swapped. Now we will get positive terminal here and negative terminal here. And during this negative half cycle, cathode of diode will be connected to positive terminal and anode of the diode will be connected to negative terminal. During this condition, the diode will be in reverse biased mode because the cathode of diode is connected to positive and anode of the diode is connected to negative, which is the violation of first condition for the forward biasing of a diode. And we know that whenever a diode is in reverse biased mode, it acts as an open circuit. So there will be no current flowing through this resistance and we will have no voltage drop across it. So we will be having 0 volt across this resistance during the negative half cycle of AC input voltage. In this case, we will be getting output voltage waveform across this load resistor, something like this. So the output voltage waveform in this circuit diagram will be like this. We are getting half wave rectified voltage across this load resistor which have the peak value of 4.3 volt. Now we will move towards this second circuit diagram. This is also a half wave rectifier, but for now the AC input voltage have peak value of 50 volt. During the positive half cycle of AC input voltage, we will be getting positive terminal here and negative terminal here. So the cathode of diode is connected to positive terminal and anode of the diode is connected to negative terminal. In this case, this diode will act as an open switch because it is in reverse biased mode, and during this cycle we will be getting no voltage on output. Now we will focus on negative half cycle of the AC input waveform. During this negative half cycle we will be getting positive terminal here and negative terminal here. In this case we will be getting negative terminal connected to cathode of the diode and positive terminal connected to anode of the diode. The first condition of the forward biasing of diode is satisfied. Now we have to confirm either the AC input voltage is greater than the potential barrier of diode or not. The peak input voltage of AC is 50 volt, which is much larger than the potential barrier of a silicon based diode. So the diode will be in forward biased or conducting mode. Whenever a silicon based diode conducts, it will have 0.7 volt across its terminal. And because the diode is in forward biased mode, so it will allow current to pass through it. So during negative half cycle of AC input voltage, we will be getting negative output voltage which will have the peak value of 49.3 volt. Here again 0.7 volt is dropped across this diode because we are considering silicon diode, and the forward drop of silicon diode is 0.7 volt. We can also see that this was a half wave rectifier, so only half cycle of AC input voltage is being rectified through this circuit. So the output voltage waveform across load resistor in this circuit will be something like this. Here I forget to mention minus sign along with the value of peak voltage. Here I have used minus sign along with the value of output voltage because we are measuring voltage with reference of this ground node. Polarity of output voltage across this load resistor will be like this. And because we are measuring voltage with respect of this ground, that's why we will be getting minus 49.3 volt. Now move towards next problem 2.12. What is the peak inverse voltage across each diode in given below figure? Now this time we have to find out peak inverse voltage across diodes in both circuit diagrams. We will start from here. As we discussed earlier, during positive half cycle of AC input voltage, we will be getting this polarity across its terminals, and due to this polarity this diode will conduct and it will be having 0.7 volt across it. But during the negative half cycle of AC input voltage, we will be getting this polarity notation across its input terminals, and due to this polarity, anode of the diode will be connected to negative terminal and cathode of the diode will be connected to positive terminal. And we also discussed during the negative half cycle of AC input voltage, the diode will act like an open switch because it is in reverse biased mode. So during negative half cycle of AC input voltage, the circuit will look like this. In this case, this circuit will have no current passing through it, so this resistance will have 0 volt across its terminals. So during the negative half cycle of AC input voltage, all voltage will be appearing across the diode, and the peak of this AC input voltage will be considered as peak inverse voltage across diode. So peak inverse voltage across this diode will be equal to 5 volt. Same case will be applied here. During negative half cycle this diode conducts, but during positive half cycle this diode do not conduct, because during positive half cycle its terminals are like this, and positive is connected to cathode while negative is connected to anode. So it will act as an open switch because of reverse biasing. And whenever it will act like an open switch, all the half cycle AC input voltage will be appearing across its terminals. And during this half cycle, the peak voltage of AC input voltage will be considered as peak inverse voltage across it. So peak inverse voltage across this diode will be equal to 50 volt. Now move towards next problem. Problem number 2.13. Calculate the average value of a half wave rectified voltage with a peak voltage value of 200 volt. In this scenario, two parameters are given. One is the peak voltage and other one is the category of rectifier. We know that in case of half wave rectifier, average voltage is equal to V peak divided by pi. Now we have to place the value of peak voltage inside this equation. Average voltage will be equal to 200 volt divided by pi. Solve this equation and we will get the average voltage 63.66 volt. So in case of half wave rectifier having the peak output voltage of 200 volt, we will be getting an average voltage 63.66 volt. Move toward the last problem. What is the peak forward current through each diode in given below figure? Again we have to focus these two circuits and we have to find peak forward current through diode in each circuit diagram. In previous problem we have found peak voltage across this 47 ohm resistance, that was 4.3 volt. Now in order to find peak forward current through this diode, we will use Ohm's law to calculate current through this resistance, and that same current will also be flowing from this diode because of series connection. So current through this resistance will be equal to voltage across it. So peak forward current through this resistance will be equal to the peak output voltage across this resistance divided by the value of resistance. 4.3 volt divided by 47 ohm, it will become 0.091 ampere. So the peak forward current through this diode will be equal to 0.091 ampere. Similar case will be here. Peak output voltage across this 3.3 kilo ohm resistance was 49.3 volt. Again we will use Ohm's law to calculate current through this resistance. 49.3 volt divided by 3.3 kilo ohm, it will become 14.93 milliampere. And this current will also be considered as peak forward current through this diode as well because of series connection. So the peak forward current of this diode will be equal to 14.93 milliampere. So this was all about chapter 2 problems 2.11 to 2.14. Thank you. See you again in next video.